Good morning, good afternoon, and good evening, everyone. So today we're going to be continuing to do exercises on finding double integrals over general regions. Okay, so let's proceed to doing number 9. This is number 8. Okay, number 9. So number 9 is telling us to find the volume of a given solid enclosed by some surface. So it's that same pattern again. So we want to find the volume of solid enclosed by paraboloid. And this paraboloid has an equation, an explicit equation for z rather. X squared plus y squared plus 1. And here's where we get our limits of integration. Planes that have x equals 0, y equals 0, z equals 0, and x plus y equals 5. Right. So we have our equation, right? But then we need to find our bounds. So how do we find our bounds here? Here we have x equals 0, y equals 0. Okay. Z equals 0, which we can plug in. X plus y equals 5. Let me think. Uh-huh. Hmm. If I plug in a 0 to z, I just get the same function. I have an x plus y equals 5, which I can rewrite into any in terms of x or y, depending on how I want to go about the problem. But yeah, that's the idea. We always have to find an integral and then solve it. So it's something I'm thinking about. Mm-hmm. What's mm, so apparently they form a triangular region, right? So here we can do something in terms of y. So here we can rewrite this as y equals 5 minus x. Now, how do we know what the limits of x are? Well, when x is 0, y is 5. And when x goes to 5, y is 0. Because it's bounded by y equals 0. Right? And so the limits of x are from 0 to 5. Then the limits of y, or the bounds of y, are from 0 to 5 minus x. And then my function is just this dy dx. Right? And so from there, I just evaluate the integral. Okay, so here I'm just going to go with the inner integral. Here I say y is a variable. There, so I've just integrated it. And then I say, okay, I'll plug in my 5 minus x to all of these. I don't need to plug in my 0 because it's just going to be 0. So I get something like this. Right? Now the thing is I can expand or I can simplify. I'm gonna expand this out. And this is I think a 1/2. And this is 5 minus x squared. Or cube, I mean. So it's basically 5 minus x 3 times. So if I try doing it the first time, 25 minus 5x minus 5x minus 10x plus x squared. Then I multiply that by 5 minus x. So here I get, or multiply everything by 5. So I get 125 minus 50x plus 5x squared. Then minus 25x minus or plus 10x squared plus minus x cubed. And then from there I should get minus x cubed minus 50, oops, plus 5 plus 10 plus 15 x squared minus these two, that's 75x plus 125. And so that's the whole thing there, right? And then I divide all of that by 3. And so I basically get, well, here I would get negative x cubed over 3. Let's just write it out. Because I'm multiplying it by a negative 1/3, right? That's what I'm doing. Oh no, it's a plus. Whoops. My bad. So it's plus 1/3, so I keep my sign. Right. So I just divide everything by 3. This becomes 5x squared. This becomes 75 divided by 3 is that thing. It is 25 minus 25x. And then 125 divided by 3, if that's a thing. That's not a thing. So I just get that. Then plus 5 minus x. So this is a long polynomial. Okay. And then from there, let me just simplify all of that stuff. So here I would get my x cubed to both sides. That's just negative 1 minus 1 over 3. That's negative 3 over 3. That's negative 4/3, right? Then this one is 10x squared. Minus 25x minus x is minus 26x. 125 plus, so this thing, or in another case, that's just 15 over 3. So 125 plus add a 15. So I get 140 over 3, right? Cool. And I think that should be it for now, right? Not gonna do too much solving yet. Then I now integrate this in terms of x. So here I do 0 to 5 of this thing. Which I think I can immediately integrate. So here I would get, so this one gives me, if I integrate x to the 4th over 4, which I can then cancel. So I would get negative x to the 4th divided by 3, right? Here I would get 10x cubed over 3. Here I would get, so this one's going to be x squared over 2. So I divide 26 by 2, and I get 13 in this case. So this gives me 13x squared. And here this just gives me for my last term 140 over 3 x. This is 0 to 5. And then from there I just solve all of this in one go by putting 5 in. So this would give me 5 to the 4th, which is negative 625. 5 cubed, 125 times 10, that's 100 or 1,250. And then this is minus 13 times 25, which is 325. Oops, not writing anything. And then this is 140 over 3 times 5, 700. So it's nice how they're all in threes, right? So this gives me, just to simplify everything, 1250 minus 635 plus 700 is 1,325 over 3 minus 325 times 3, it's 975. And then this is 350 over 3, which I think that was the answer, if I'm not mistaken. Yes. That's how long it is to do these computations. I mean, there could have been a quicker way, maybe. Not super sure. I decided to expand it out. But yeah, I think there might have been a quicker way for me to do all of these. Maybe split the integral into certain pieces so that we can make it easier. And then just add them all up together. That's also another thing, instead of doing it all in one go. Okay, let's try this. Number 10. So here I'm being asked to find a volume of a particular solid. And this solid is bounded. So here, this is where we talk about limits of integration. It's bounded by coordinate planes with an S, and the plane 6x plus 5y plus z, which is equal to 30. So when we say coordinate planes, we actually just mean when we're at the planes, exactly at the planes. When x is 0, when y is 0, when z is 0. The xy plane is bounded by the xy plane, the yz plane, and the xz plane. Now, how do we go about that? So first is find the integral. So here maybe I would kind of isolate z. So that would be a function. I would make it 0. If I make it 0, this is just that. Now maybe I would find some sort of connections here. And when x is 0, y is 0. Pretty sure that's a bound. Z is 0. Plane is this. Okay. I could try to find something in terms of the other. So let's say if I make this 0, now I have something of x and y. Then I could make it so that I can get y, the bound of y. Or I could also do it so that I can get a bound of x. So here in this case, maybe just get a bound of y. So this would give me that. When I make my x or my z 0, right? This becomes 30. And then I could take out the signs. Oops. I write 5y, 6x. I could divide it all by wait a minute. Because if you multiply these two, you get 30. Anyway, Okay, let me do it in terms of y maybe. Now, if I divide everything by 5, oh, I get something. Okay, let's try a different way. To me, that felt like, okay, maybe I need to try something else. Because I can already see how complicated it looks like, right? So we're gonna have to try a different way. Mm, oh, so that's the idea. I want to determine the region of integration. Oh shoot, I was doing it correctly. Whoops. Yeah, that was the correct way to do it. So the idea was to get this function out and then to sort of isolate this thing, right? And then from there, I isolate my y. So it gets something like this. Then my y is just divide everything by 5. So then I would get 6 minus 6 over 5x. Yeah, so I was right there. And so here the idea being, I know my x goes from 0 to something. My y goes from 0 to something, or 0 to this thing, right? Now, how do I determine what my x is going to be? So if my y goes from 0, if I make the 0, y is 6, right? It's just a line. So here again, we have a triangular region, I think. Just a hunch. The x-intercept is found by setting y is equal to 0. And so that's going to be 6x equals 30. So if we set this to 0, that's 6x equals 30. X is 5. And if we set x to 0, then 5y equals 30, y is 6. Hmm. So it's just making use of these information in order to find bounds. So in this case here, if y is 0, 6x equals 30, x equals 5. And that's where they found x equals 5. Another way we could have done it was get y, or in this case, yeah, we get y equals, or we get x equals 0. Y is going to be 6, so we have bounds from 0 to 6. 0 and 6. And then from there, we can solve for this thing in terms of x. But then we would have to do dx dy, right? So here, just to set up the integral, x is from 0 to 5, y is from 0 to this thing here, And this is 30 minus 6x plus 5y. And then first we integrate by dy and then by dx, right? So that's pretty much the idea behind it. So here, just to quickly do that, and I can already see it's kind of complicated-ish. So first thing is we integrate this thing. We take the antiderivative. This is 30y. This is minus 6xy. This is 5 halves y squared of these bounds. I'm not going to put the 0 anymore because that would make everything 0. Instead, I'm going to put my upper bound. Plug in my upper bound, 6x of this. And you can see how, and I think I haven't pointed it out, but at every item that we did, now we have something, or everything rather, in terms of x after we integrate, right? Then this is, oh, this thing is squared. Okay. Do I want to simplify? Not super sure now. I kind of don't want to, but it's okay. Sure, let's just do it. 180 minus, and this one I just take out my 5. This becomes 6, so minus 36, I believe, if I'm not mistaken. I could even just go the normal way, just multiply it 180 divided by 5. It should give me 36. Oh, fine. Then this one is minus 36 again. Then this one's a plus 36. Then this one's a plus 5 halves 6, so that's 30 over 2. It's 15. 1, 3, 15. Then this one is minus. Oh, shoot, my bad. So this one is. Forgot to expand this out. So this should give me 36 minus 36 over 5 minus 36 over 5. So 36 times 2, 72. Then this one is square that thing. So this gives me 36 over 25 x squared. So I get a value like this. Okay. And then from there, let me try to simplify a bit maybe. So here I get 180. This is minus 72. If I'm not mistaken, 2167. Then this is same. Now this is where it starts to get different. Here I would cancel this. This becomes 1, this becomes 5. 1, this becomes something else. 36 divided by 2 is 18. So I would get 18 over 5 here. X squared. Then we try doing it the same for the others. Oops. Here I can also cancel out my 5. I can cancel out my 2. This becomes 1. 72 divided by 2 becomes 36. I get minus 36x. Oh, okay. Oh, I forgot the x here. Whoops. And then here, I think this just gives me a nice number when I multiply this by this. 36 divided by 2 gives me 18. I multiply that by 5, gives me 90. There we go. Nice. And then just to clean it up, it's a polynomial. Or actually, it's a quadratic one. So we have to add these two together. 36 over 5 plus 18 over 5. 54 over 5. Negative 72 minus 36. So I kind of just add them in a way. It's minus 108. And then I add my 180 plus 90, which I think is 270. Yeah. And there we have it. That's the first part. And then from there, we integrate this from 0 to 5. Dx. So how would this look like? This is x cubed over 3. This is going to be 15. And then this is 108 over 2. That's 54 x squared. And then this is 270x from 0 to 5. Then I just plug in everything 5 related, and I should be good to go. So here, 5 to the cube, 125, and 15. If this were 15, or 125 rather, this was 15, then this would be 25, this would be 3. And so 25 times 54 would give me 1350 over 3. Okay. Whoops. Kind of erased it. 5? Hold on, what did I do? Oh, 15. Oops. And then this one I just do 54 times 5 squared, that's 25, 1350. Okay. And then here I just do 270, multiply that by 5, 1350. Oh, look at that. I got a number like this. So if I'm not wrong, obviously I'm wrong. Or unless I could simplify that. Oh, I could. 450, but it's not the number I need. So I probably messed up somewhere, I think. From up here, maybe? Oh, wait a minute. I did a Y here. Oh, whoops. I did plus. It's supposed to be minus. Why is that? 30 minus 6x minus 5y. Anyway, then that affects everything. This one should have been minus. or at least just that part, right? So these are y's. Okay, I don't think I messed up any of the other parts here. This minus. Where in the world did I mess up? Maybe the signs. I was thinking of the signs here. This is minus instead of plus. This is plus instead of minus. Then this is, I'm just doing it in reverse. And then this is minus. Minus plus minus. Okay, then that affected this one. Yeah. So here this should have given me 18. It should have been 18. And then minus 72 plus 36. So that's minus 36. Then this is the same. No, it's not. This is 90. And so yeah. So again, when you mess up one of them, you mess up all of them. Pretty much how this thing goes. This is 18, 36, 90. Here, this is 18. Oops. Let me just do everything again. So here, this is yeah. So there are some times where I would just mess up the equation itself. That's embarrassing. Okay, this is 18 over 15. Then this is x cubed. This is, I think, 18 again. X squared. And this one is 90x from 0 to 5. Then I just multiply everything by 5. So here again, I get 5 cubed. That's 125. And then I get to cancel that. So this becomes 3. This becomes 25. 25 times 18 is 450 over 3. And here this is minus 18 times 25. That's 450. Then this is 90 times 5, which is 450. And so here I just get 450 over 3, which is 150. And that should be my answer. Nice. I erased all of that. So that's the idea of that. Okay, we have a couple more. 11, 12, 13, 14. I have 4 more. Let's just do all of them and then call it a day. So here I'm being asked again to find volume. So the thing is, I just woke up like early in the morning. So I'm still kind of anyways, we should be good here. This is the volume of the solid bounded by some cylinder. The cylinder has an equation x squared plus y squared equals 16. So we know that's a trace in the xy plane. And we also have planes. We have planes. Y equals 2y. Oops, y equals 2z. My bad. X equals 0, y equals 0. So we know x and y as zeros are bounds. Now I need to find the other one. So another fun fact that maybe we could incorporate is when this is true, this is true. some of these tricky stuff again. Hmm. Yeah, it's one of these again. I think personally the most tricky one is this finding bounds because it's kind of different for each figure. There's no perfect way to do it. Oh my God. That's not good. Yeah, because when I search it up, it's always going to be a triple integral when I want it to be in double integral. Okay, here he did dx dy. So he did something of x here. Y goes from 0 to 4, I'm assuming, because that's a circle. Oh, but then so here again, my function should be of z. So that's y half. And so from here, I can immediately say, oh, okay, maybe we can integrate by y first or something. But no, the thing is you have to integrate by x first. Yeah, we have to integrate by x first. Oh, and then we change these stuff. So here my y is 0. Here I can say this is that cylinder equation. Then y is plus minus that. Then we know it starts from 0, so it has to be square root the positive one. I could go negative, but then that would have been a different story. Because then this would be my lower bounds, right? Oh, whoops, why am I doing this? I meant x. Not bad. It's the same thing. When I do it for x, I get something like this. Let me just go straight to the point. I got this. I get that, right? And so my integral here would be from 0 to 4, from 0 to this thing, of y half dx dy, right? And then from there, I can start integrating 1 half y of x, or yx. Just make it yx. I like putting my numbers up front. Okay, so here I would get y of this thing divided by 2. Now, okay, now I integrate this in terms of y. What do I notice? Hmm, I could do a u sub, surprisingly. Do a u sub here. I don't need to do any trig sub or any of that. because that one, I just totally forgot how to do that. And if I reviewed, then I would probably remember. Then here I just do some u sub. I'm gonna assign this as my u. So my derivative is negative 2y dy. So my dy is du for negative 2y. And so when my y is 0, my u is 16. And when my y is 4, my u is 0. Oh. And so that means I have 1/2 from 16 to 0, right? That makes sense. Oh, but then I have a negative to save it. So I have y square root u. This cancels. I'm gonna plop that negative out. That way this switches. So I have 1/4. 0, 16 square root u du. Right? Now I have that because I kind of saved it. I put the negative out and then this just switches bounds. And then from there I can just say I can clearly integrate this thing. So I have 1/2, which would give me, when I integrate plus 1, that's 2/3, 3/2 here. And then just multiply everything by, I multiply 16 there, and then that should be it. 16 to the power of 3/2 is 64. So also I get to cancel this for fun. Oh, but then I have a 64, so I have 1/2. Now I get to cancel this. Which I think is 32. 32/3. Yeah. Okay, we have 3 more. These exercises are really long. Like, they're really something. So for number 12, I reverse the order of integration. So mostly, okay, so these items are reversing order of integration. I'm going to say 0 to 2, 3y to 6, 70 x squared dx dy. Yeah, and then here I start integrating with respect to x. So here I can just slowly pick this out. Dx Oh, I want to reverse the order. Oops, my bad. So how do I reverse the order of this thing? Basically, what I'm saying is this has to be dy dx. So my function stays, but then I don't think I can just kind of switch this whole thing. So there was actually a way to do this, which is funny. Yeah, I'm looking at the cheat sheet. So here was dy dx. They wanted to be switched to dx dy. So I actually need to draw the bounds first. That's what I need to do. So from here, like I need to draw the bounds. And then from there, determine what exactly they are, right? Let me just go over what I mean. So here I'm saying that 0 is in between. This is my y. Let me do my x first. Then my y is in between. My bad. 3y. There we go. That's my first. And this one's my y from 0 to 2, right? And then from there, how do I come up with a new bounds? So I want this to be, here's the thing. I want this to be dy dx. Here I see that x is 3y, x is 6, y is 0, y is 2. So the way I would create a new bounds is to set y to something, right? So here y is x over 3, x is 6, y is 0, y is 2. Done. Now I actually have new bounds here. So the new bounds is this for my y instead of x, right? So I would have for my x 2 to 6. Then for my y, I would have 0 to x over 3. How do I know? I plug in an x. I plug in an x between, oh wait, why do I have all y's here? What the? Okay, I plug in x equals 6 here. And I see I get, okay, 6 over 3. Okay, what the? Where did I get? Wait a minute. Oh, and then after I get this, I plug in 6 here and then I get 2. Right? So when I plug in something there, I get x equals 2. And so that's where I get the fixed x bounds. And then from there, I just solve this thing. 70x squared dy dx, right? Now I have it in dy dx. And then from there, okay, I just solve this thing. Put the 7 out. Actually, I can put everything out, believe it or not. So let me just do that. This is y. So here I get 7ex squared x over 3. And this is why I integrate with x here. I take out my 7/3. Oh, now this is interesting. Because now I get something like this. I think I could do a use of here. Let me just try. If my u is x squared, my derivative is 2x dx. So my dx is du over 2x. Oh, and so when my x is 2, my u is 4. When my x is 6, my u is 36. Because I basically just square all of them. So here I would get 7/3, 4, 36, e to the u, x, du over 2x. So that way this cancels, right? So I could use some, surprisingly. This is e to the u, du, right? And so this is just 7/3, e to the u, 4, 36. And so yes, this gives me e to the 36 minus e to the fourth. It's e to the fourth. No, it's not. I messed up somewhere. What did I do now? Okay. Oh, so it's my x values. Mm-hmm. Just double checking where I messed up. Oh, so based on this function for my 3y or y equals x over 3, I have to find some x values that work. So 6 works, but then I need to find when it's 0. So that's when x is also equal to 0. When y is 0, what is x? 0. When y is 2, what is x? 6. So this has to be 0. It was all good here, and then, oh, oops. Did not mean to do that. So this is 0. 0, 0, 0. E to the 0 is just 1. There we go. More reverse the integration, but I think it's just getting worse and worse. uh, yeah, let's try. See if we can get. This is from 0 to 1. This is arc sine y. By half. This is I don't like working with trig. Cosine x is 25 plus cosine squared x is dy. Oops, dx dy. So my idea is, or the goal is to make this dy dx. Find a new integral that does that. So again, I label my bounds. So this one's in terms of x, I think. Yeah. So this is arcsine y. So these are my bounds of x. These are my bounds of y. So I have x is arcsine y, x is pi half, y is 0, y is 1. I could rewrite this as y is sine x, right? I could do that. Now I need to find, okay, so from 0 to sine x, and I need to find when, I just basically plug everything in. When y is 0, what's sine x? 0, right? So that's the extra thing that we need here. And when y is 1, well, what's sine x? Probably pi half, right? So there's our bounds. Okay, so for x, it's going to be from 0 to pi half. For our y, it's going to be 0 to sine x of the same thing. Let's hope I didn't mess anything up. Okay. Yeah, and then from there, we just solve this integral, which I think might be harder than it looks like. What is this? I can't do a use of. Can I do a use of? Worth a try. Let's see if I can do it. Oh, but I have dy. Oh, okay, so this isn't a bother. Yeah, no bother. So here I basically just have this. I just treat all of these as a number. Then here I integrate some y value. And so this should give me cosine times sine. I think there was a formula for that. Okay, I know there's like some formulas for this. I'm gonna leave it as it is for now, maybe. Kind of like that. Yeah, something like this was the formula. Cosine sine. And I think I could make this even nicer. This is 1/2 sine of 2x. Then that thing here. Yeah, I know there was a formula that goes something like that. And then from there, I integrate that thing from 0 to pi over 2. Now here's where the messy part begins. Okay, dx. I was thinking of doing a U sub, but then this looks frightening. U sub doesn't work. Wait, does it? Another thing I'm thinking of is integration by parts, which I think might work better. If I do a U here, what might happen? Was that better to do? If I do a U sub, I'm just curious what might happen because I can't quite visualize it. This is 0. This is 2 of this. Derivative is this. Oh, this would have been better. Okay, so I didn't need to do the trig thing. Whoops. I should have just left it like that. Yeah, because I could have canceled all of it. So here I would get something like 0 pi half. This whole thing. Cosine squared dx. And then here I just do a nice U sub. I don't need to do some complicated integration by parts. No need. So that's just a U sub here. So my du is 2 cosine sine, or negative sine actually. Dx. Right? And then so here when my x is 0, my u is cosine 0 was that? It's 1, right? 1 squared, this is 26. Then when my x is pi half, that's 0. That's just 25. Right? So I get something like this from 26 to 25. This square root u du over 2 cosine x minus sine x. And what happens here? I get to cancel this and this. I get to cancel this and this. And then the sign switches. So I get 1/2, 25 to 26 square root u du. Right? Nice. And then from there I get 1/2. Then this was, I think, 3, 2 over 3 u 3 over 2. 25 to 26. There we go. Nice U sub. Here I get 1/3 of 20. What's this? 26 3 over 2 minus 25 3 over 2. If there's a way to. This one's 125. Let me see this. 26 3/2 is the same as 26 1/2 to the third square root 26 to the third. Yeah, it's the same thing. Okay. Because I wrote my answer differently the previous time, which was, I think, 26 square root of 26. It's the same thing as this. Yeah. There's not even like trig related stuff. It was just evaluating and making it more annoyingly complex when it doesn't need to be. Anyway, okay, again, reverse order. This is the last item for the day. 0 to 27. This one was 3 cube root of y to the 3, and then 8 e x to the fourth dx dy. So I want to change it. So again, I state my bounds, right? So my x is in between these two. My y is in between these two. And so my x has bounds 3 cube root y has 0, y has 27. Now I want to switch the rows of that. This becomes x equals 3. This becomes, what is this? Y to the 1/3-ish, right? What does that look like? Ah, let me put numbers. Maybe that will help. This could be like, let's say 8. This could be 2. Oh, so it's just x squared, x cubed. Knew it. Putting these are really helpful. Then from there, when x is, now I need to find fixed bounds for my x. When x is 3, this is, or actually I need to plug in the zeros here. When y is 0, x is 0. When y is 27, x is 3. So that's the other bound. So again, I need this to be dy dx. So my x is from 0 to 3. My y is from 0 to x cubed. Oh, that's so nice. And then I have the same function here, dy dx. And then I just solve for it. So that's all a number. So I get y here actually. I basically get this 8 x to the fourth x cubed. That's it. Then from there, I go from 0 to 3, simply evaluating that whole thing I just did. I could take out my 8, I mean. And what else can I do? I could do a u sub. I could say that's x to the fourth. Oh, that looks nice. Du then is going to be 4x cubed dx. Yeah. Then the x is du divided by 4x cubed. And then when when my x is 0, u is 0. And when my x is 3, u is 3 to the fourth. Was that 81? Very unusual number. This is e to the u. X cubed is I'll leave it be. Then my dx, I get to take these out. This one cancels, it just becomes 2. Now I have e to the u du, right? And then from there, I get to integrate this thing. I get to, I think this is just e to the 81 minus 1. Because e to the 0 is just 1. That's my answer. Yeah. Okay, so that's it. That's all gonna be for this video. I hope you guys enjoyed, learned a lot, and yeah, I'll see you guys in the next one.